Hey class, Absolute 5 here, and today we're going to talk about the chain rule. Now, what is the chain rule? Chain rule doesn't actually mean bondage or chains, and specifically not in the literal sense, but chain rule meaning two things are happening at the same time, mainly like a chain reaction, so to speak. So let's write the definition of what the chain rule is. So let's see. It states if F and G are both differentiable, and F is equal to the composition of F of G, which is a composite function, a function within a function pretty much, defined by F of X is equal to F composition of G of X, then F is differentiable and F prime is given by the product F prime of X is equal to F prime of G of X times G prime of X. So what this is essentially saying, what this definition is saying about the chain rule is that if you want to take the derivative of a composite function, because you know we have a function in another function, right? So when that happens, you want to take the derivative of it. So you want to find out if you were to, we already know that you can't just distribute the derivative into just F prime, G prime. We already proved that that's not true. You can't do that. So when you do the derivative of this, you have to take the outer function, the derivative of the outer function, and then times by the derivative of the inner function. So instead of working your way in and out, you work your way out to the in part of the function. So you work your way from the outer function to the inner function. So let's see that with an example. Okay, so inner and outer functions. Again, concept is like inception, just instead of the inside out, you're working the outside in. So the example is find F prime of X if F of X is equal to the square root of X squared plus 1. Now, here we see a whole bunch of things going on at once. We see an X squared plus 1, but they're under the square root of the function. So, before we even take the derivative of this, let's rewrite this. F of X is equal to X squared plus 1 in parentheses being raised to the 1/2 power. So remember, the square root can be rewritten as a 1/2 power. So now if you notice, we see that this is a base and this is an exponent, but at the same time, the base has an X squared. That's how you can see that there's two functions within each other. So now let U, or whatever letter you want it to be, M, R, I don't know, let U equal X squared plus 1. And when we say du, we're saying the derivative of this becomes 2x, because when you differentiate these two, the number becomes 0, because a constant function is always 0. The slope is always 0 for that function. So, why am I doing this? Because we're trying to set up the formula. Remember, the chain rule, F prime of X is F prime of G of X times G prime of X. I'm already setting up for G prime of X because the outer function, we know the derivative of the outer function is going to be, if you remember the power rule, you bring this in front. The 1/2 power goes in front, and we're going to let U equal this. So it's going to be U, I subtract 1, so it becomes -1/2. So then, using some algebra, if you remember, this -1/2 is affecting the U, so it becomes 1/2U to the 1/2 power. So then, so you can clearly see that we have the derivative here of the first function. You see that? The outer function, because this is the outer function. This is the outer function, and then we need to multiply it by the derivative of the inner function, which is the inner function is x, 2x. So it's going to be times, well, in this case, times du. Then we're going to change everything from u's back to x's, so we get what? We simply just change it. So it just becomes 2. I'm going to change this back to the square root. The square root of x squared plus 1, that's exactly what u was, remember? Times du, which is just going to be 2x. So if I multiply, I get 2x. You probably can't see that. You get 2x over the 2 square root of x squared plus 1, right? The 2's cancels, and your answer is x over square root of x squared plus 1. So ideally with chain rule, you got to be careful with how you start off with everything first. Like when I say start off, I mean you want to take the derivative and use substitution when you want to find what the inner function is. We do this because it's easier to see that. This is kind of hard to see that this is a base and this is an exponent. It's hard to see that. But when you simplify this to become like one thing, if this was, let's say, x to the negative, let's say this is x to the 1/2 power, then you can see, hey, this is how it is. This looks doable. So that's the lesson for you guys today. This has been Absolute 5. I'm Raja Palomino, and always remember to like, share, and subscribe to this channel. Be sure to hit that bell button next to the subscribe button. And I'll see you next time for another math lesson today, guys, okay? So don't forget, math is infinite because there are infinitely many possibilities. Have a good one, okay?